Right now, deep space, almost nothing here, but something is coming. There are flash gone in a millisecond and it will happen again. That dish has been listening for years. Most nights it hears nothing, but some nights it hears something it can't explain. This is what it looks like when it arrives. A single spike out of silence and then nothing again. The signal came from that direction, from something unimaginably far away. Something that found us. Every 16 days, a mark then another. Then another perfectly spaced, like a clock that never loses a second. There it is again. Same source, same power, exactly on schedule. The person who first saw this data sat very still for a long time because what they were looking at didn't fit anything in the textbooks. Down there are 8 billion people who have no idea this signal exists. Up here, something has been trying to reach that planet for longer than humans have been alive. Every dot in this image is a galaxy. Billions of them, and from somewhere inside one of them, something keeps sending. Look at the spacing between these peaks. Equal precise nature is rarely this clean. This telescope is one of the largest ears humanity has ever built, and even it almost missed what it was hearing. The signal is coming again. We know, when we don't know what's sending it. To understand how powerful this signal is, start here. The sun, the most powerful thing most humans will ever think about. Now watch it shrink smaller, until it's just one star among hundreds of billions. The entire Milky Way, every star in it, every planet in 1 millisecond. A fast radio burst releases more energy than our sun produces in thousands of years. The signal expands outward in all directions, moving at the speed of light through emptiness so vast it has no name. 1 millisecond, that is how long the signal lasts, less than a blink, and in that moment, it outshines entire galaxies. The signal has been traveling for longer than complex life has existed on Earth. It left before there were eyes to see it, before there were ears to hear it. When this signal began its journey, Earth was a ball of molten rock. Nothing on its surface could have imagined what was coming. When the signal was halfway here, creatures like this ruled the planet. They had no concept of radio waves or galaxies or signals from the dark. And now the signal reaches a planet that has built machines specifically designed to catch it. The timing is either coincidence or it isn't. When scientists plot the signal's frequency over time, they see something called a dispersion sweep. The higher frequencies arrive first. The lower ones follow like a fingerprint from deep space. Between the source and us lies intergalactic space, not just empty, profoundly empty temperatures near absolute zero, almost nothing for millions of light years in any direction. And yet the signal crosses all of that intact structure, carrying information about every cloud of gas it passed through on the way. When it finally arrives, it hits the dish, converts to data, and appears on a screen as a spike that lasts less than a heartbeat. The year is 2007. A scientist named Duncan Lorimer is going through old telescope data from 2001. He almost doesn't notice it almost. There on the screen, a signal unlike anything in the archive. Too bright, too short, coming from the wrong direction. To be anything local. This is what he saw, one spike clean, sharp appearing once and never again in that data set. He didn't know what to do with it. He published the finding. Most of his colleagues thought it was interference, a glitch, something the telescope picked up from a passing aircraft or a nearby electronic device. For a while, some researchers actually believed the signals were coming from microwave ovens in the observatory kitchen. That is how reluctant science was to accept what the data was showing. Then in 2013, 4 more signals. Same characteristics, different times, different locations in the sky. This was not microwave interference. This was real. Within a few years, the signals were coming from everywhere. Above, below, left, right, uniformly distributed across the entire sky. Which means they are coming from outside the galaxy, from the universe itself. CHIME in Canada changed everything. A telescope that doesn't move, that watches half the sky every day. It started finding fast radio bursts, faster than anyone could process them. Inside CHIME, the structure looks almost alien. Rows of receivers, kilometers of cable, all listening, all the time. On an average day, the data from CHIME is quiet. Noise, known sources, expected signals. And then sometimes, a spike that shouldn't be there. This galaxy, 3 billion light years away, became the most important object in astronomy in 2016. Because something inside it refused to stay quiet. Deep inside this galaxy, in a region dense with young stars, something keeps firing. Again and again, with no sign of stopping. 3 billion light years. If you could travel at the speed of light, You would need 3 billion years to get there. The universe is only 14 billion years old, and yet the signal crosses that distance, reaches our instruments, enters our data, and asks a question we don't yet know how to answer. November 2016, the Arecibo telescope in Puerto Rico detects the same source again. FRB 121102 has repeated. For the first time in history, a fast radio burst has come back. Look at this. Multiple bursts, same source, same location. Whatever is creating the signal, it is still there, still active, still sending. The scientific community had been skeptical. Now they were paying attention. A repeating source means you can study it, point a telescope at it, wait, and it will perform again. To pinpoint the exact location, scientists used radio interferometry, telescopes on opposite sides of the Earth working together, like a planet-sized ear pressed against the universe. The source lives here, in a dwarf galaxy, small, irregular, but packed with young stars and violent magnetic environments. And inside that galaxy, this point, something at this exact location is producing bursts of energy that outshine the entire rest of the galaxy combined, repeatedly. In 2020 alone, astronomers detected over 1,000 bursts from FRB 102 in 47 days. 1,000 in 47 days. Whatever this is, it is not slowing down. The signal is also highly polarized, rotating as it travels. This tells scientists that the source sits inside an environment with an extraordinarily powerful magnetic field, among the strongest ever measured. The leading candidate for that environment, a magnetar, a neutron star with a magnetic field so intense it would stop your heart from the distance of half the moon. 1 cubic centimeter of a neutron star weighs 1 billion tons. Its surface temperature exceeds 1,000,000 degrees, and its magnetic field is 1 trillion times stronger than Earth's. This is what we think is sending the signal. Then, in 2020, CHIME found something that changed the question entirely. FRB 2018-0916b, a repeating source, but this one had a pattern. Active for 4 days, silent for 12. Like a metronome that never drifts, never varies, never misses a beat. The source is here, in a spiral galaxy, 500 million light-years away. Closer than FRB 102, close enough to study in detail. Both are so far beyond human comprehension that the difference is meaningless. One possible explanation for the 16-day cycle, 2 objects orbiting each other. Every 16 days the geometry changes, the signal becomes visible to us, then it doesn't. A neutron star orbiting a companion. Every 16 days its beam sweeps through the right angle. We see it, then it rotates away. We don't. But here's where the models start to break down. A 16-day orbital period requires a companion star of specific size and distance. The numbers work on paper, but barely. Another explanation, precession. The neutron star is wobbling like a spinning top. Its beam slowly sweeps through space. Every 16 days it points our way. Scientists built mathematical models, then rebuilt them, then modified them. Each model explains part of the data, none explains all of it. The signal keeps arriving. The explanation keeps failing. CHIME keeps watching. Every time the 16-day window opens, the telescope is ready. And every time, without exception, the signal arrives. 4 days of activity. The window is open. Something is sending. We are receiving. Then it stops. 12 days of silence. The window closes. We wait. The waiting is the strangest part. We know exactly when the signal will return. We point the telescope at empty sky, and we count the days. Day 16. The window opens and the signal is there, exactly where it promised to be. In those 4 days of activity, the signal fires dozens of times, sometimes hundreds. Whatever is sending this, it has a lot to say. Somewhere out there, right now, something is counting. 16 days, with a precision that has never failed. 3 theories, 3 attempts to explain what no one fully understands. And 1 possibility that most scientists won't put in their papers. Theory 1, a magnetar, the most accepted explanation. A neutron star with a magnetic field so powerful that space itself distorts around it. On the surface of a magnetar, the crust can crack. A starquake. When it does, the magnetic field reconfigures in an instant and releases a burst of energy we can detect from billions of light years away. In 2020, a magnetar in our own galaxy, SGR 1935 plus 2154 produced a radio burst similar to a fast radio burst. For the first time, we watched it happen from inside the same galaxy. But magnetars don't naturally orbit with a 16-day period. The cycle doesn't fit the model. Something else has to explain the timing. And that something is still unknown. Theory 2, a binary system. A neutron star orbiting a massive companion. The companion's stellar wind periodically blocks the signal, creating the on and off pattern we observe. For 12 days the wind is in the way, the signal is blocked. For 4 days the geometry clears. The signal gets through. Elegant, almost too elegant. Then the window closes again, the wind returns, the signal disappears, and we wait for the next orbit to bring it back into view. But FRB 2018-0916 billion sits on the edge of a spiral galaxy arm, in a region of active star formation. The companion star required by this model should be visible. It isn't. Theory 3, Precession. The neutron star is wobbling. Its beam sweeps through space like a lighthouse. Every 16 days, it sweeps past Earth. We see it, then we don't. A lighthouse doesn't know who it's warning. It just turns, over and over, sending its signal into the dark, whether anyone is watching or not. But the precession rate required to produce a 16-day cycle is unusually fast for a neutron star. The physics is possible, but not comfortable. 3 theories. Each one explains something. None explains everything. The signal keeps arriving. The debate continues. And then there is the 4th possibility. The one that doesn't appear in most papers. The one scientists mention quietly, if at all. The signal is too clean, too regular. Natural processes have variations, turbulence, noise, imperfection. This signal has almost none of that. Compare a natural astrophysical signal to FRB 2018-0916b. One looks like weather. The other looks like engineering. No scientist is willing to say that publicly without extraordinary evidence. But several have noted privately that if you were designing a beacon, this is roughly what it would look like. Something out there is counting. 16 days. 16 days. And we are finally listening. SETI has been searching for signals from other civilizations for 60 years. So far, silence. Except for a few signals that were never fully explained. The Drake equation tries to calculate how many civilizations might exist in the galaxy. The variables are uncertain, but the logic is sound. We are probably not the first. We are probably not alone. The Fermi paradox asks the obvious follow-up question. If civilizations exist, where is everyone? The universe is silent, except for these bursts, coming from everywhere, on no schedule we understand, except one. The several researchers have formally analyzed fast radio bursts for signs of artificial origin. Their papers were published in peer-reviewed journals. The conclusion was not that FRBs are artificial. The conclusion was that we cannot rule it out. The energy required to produce a single fast radio burst artificially would require harvesting the total output of a star, a Type 2 civilization on the Kardashev scale, a civilization that has mastered its entire solar system, a Dyson sphere, a structure built around a star to capture all its energy. If such a thing exists, it would produce exactly the kind of energy budget needed to generate signals visible across billions of light years. There is a theory proposed by Harvard astronomers. Fast radio bursts are the exhaust, a beam of focused energy accelerating a light sail, a spacecraft, at a fraction of the speed of light. What we detect is the leakage from that beam. Each pulse would be accelerating an object, the mass of a large ship, to speeds approaching light. The engineering required is beyond anything we can imagine, but it is not beyond the laws of physics. Most scientists consider this the last resort explanation. After all natural mechanisms have failed, you consider the unnatural ones. Natural mechanisms have not yet fully failed, but they are struggling. The signals come from all directions, uniformly distributed across the sky. This means whatever is producing them is not concentrated in one place. It is everywhere, in every direction, across the entire observable universe. In 2025, astronomers have cataloged over 1,000 fast radio bursts. The number doubles roughly every 2 years. As telescopes improve, as detection methods sharpen, the universe is more full of these signals than anyone initially expected. And then there is this, a fast radio burst from inside our own galaxy, not billions of light years away, but right here in the Milky Way. Which means whatever produces these signals is not only out there, it is in here too. The square-kilometer array is being built right now. Thousands of antennas across 2 continents. When operational, it will detect thousands of fast radio bursts every single day. The dataset will be unlike anything we have ever had. In that dataset, patterns will emerge. Some will be explainable, some will fit the magnetar model, some will fit the binary model, and some, possibly, will not fit any natural model at all. If that happens, if a signal is found with a pattern too precise, too structured, too intentional to be natural, the world will be very quiet for a moment, and then very loud. Somewhere out there, something is counting. We know when the next signal will arrive. We do not know what will be different about it when it does. 8 billion people on this planet. Most of them have never heard of fast radio bursts. None of them consented to being the recipients of whatever this is. The telescope is already pointed at the source. The window opens in a few days. The data will arrive. The scientists will analyze it. And the question will remain. He has been doing this for years. Watching clocks, checking coordinates, waiting for something to say. Something new. So far, it just keeps saying the same thing. On schedule. 16 days, 15, 14. The source doesn't know we're counting. Or maybe it does. Right now, at this moment, while you watch this, something in that galaxy is in the process of producing a signal that will reach Earth in 500 million years. Whatever receives it will not be us. And right now, something in that galaxy just fired. We won't know it happened for 500 million years. The universe operates on timescales that make human history feel like a single breath. When the signal we received today was sent, Earth looked like this. Single-celled organisms in warm, shallow oceans, no eyes, no ears, no one to wonder about signals from space. Life was just beginning to experiment with complexity. Multi-celled organisms, the first animals. The signal flew past all of it, patient, constant, indifferent. Dinosaurs appeared, ruled for 160 million years, were destroyed in a day. The signal flew past all of that too, never slowing, never stopping. 300,000 years ago, something new appeared on this planet. Something that would eventually build radio telescopes. The signal was almost here. And then, we built the right machine, pointed it at the right piece of sky, and the signal arrived. As if it had been waiting for exactly this moment. The data is recorded, saved, analyzed, and the answer is still, we don't know. A flash, a telescope, a galaxy, a signal, a planet, a question with no answer yet. Down there, 8 billion people. The signal found them. They just don't know it yet. The telescope is ready, the coordinates are set, the window opens soon, and the signal will arrive, because it always does. Somewhere in that sky, above that telescope, above all of us, the source is already preparing its next transmission. It has never missed a deadline. There, one more time, the signal, exactly when it said it would be. And then, dark, silence, 12 days of nothing. We wait again. That galaxy. Quiet, beautiful, holding its secret. Whatever is inside it, it is not concerned with being understood. And here we are, small, listening, trying to understand something that may be beyond our current ability to understand. But we keep trying. Every major radio telescope on Earth has now observed a fast radio burst. They all agree on what the data shows. They do not all agree on what the data means. And when the square kilometer array is complete, when we can hear thousands of these signals every day, the answer will either become obvious or the mystery will become much deeper. Millions of signals, millions of patterns. Some will be magnetars, some will be binary systems, and maybe one will be something else entirely. If the answer is physics, we will learn things about extreme matter and energy that will reshape science. Fast radio bursts may be the key to understanding the universe's most violent objects. If the answer is something else, then that single blinking point in the dark changes everything we thought we knew about our place in the universe. We are here, small, listening, on a pale blue point orbiting an ordinary star in an unremarkable galaxy. And something has been sending us a signal for longer than we have existed. A flash, a dish, a galaxy, a question. No answer yet. We move toward it now, in imagination only, because no machine we have can close this distance. We can only listen.